people, it's you can sit if you want to.
Oh, okay.
But we'll have to get you the clicker.
Okay.
Good afternoon, everyone. Welcome back from lunch. We are about to resume the hearing. Our next panel will discuss perspectives on ethics and common principles in algorithms, artificial intelligence, and predictive analytics. My name is Jim Trilling. I am an attorney in the FTC's Division of Privacy and Identity Protection, and I will be co-moderating the panel along with Karen Goldman, who, if you were tuned in or attending this morning, you've already met. Karen is an attorney in the FTC's Office of Policy Planning. We are pleased to have a great group of 6 panelists to discuss ethics and common principles related to artificial intelligence. The format for this panel will be similar to the last one. Each panelist will make a presentation, and then we will have a discussion about issues that are raised in the presentations. We again welcome questions from the audience. Note cards are available for you to provide questions if you want to write them down during the panel. I'm briefly going to introduce our esteemed panelists in the order in which they will be presented. In the order in which they will be presenting. You can find more detailed information about each panelist in the biographies that we have printed and made available on our website. Our first panelist is James Folds, an assistant professor at the University of Maryland, Baltimore County. Following James will be Mark McCarthy, senior vice president for public policy at the Software and Information Industry Association. Then we'll hear from Dr. Ruman Chowdhury, the global lead for responsible artificial intelligence at Accenture. Then Martin Wattenberg, a senior staff research scientist at Google. Then Erica Brown-Lee, a senior vice president and assistant general counsel at MasterCard. And finally, from Naomi Lefkowitz, a senior privacy policy advisor at the National Institute of Standards and Technology. And with that, I'm going to turn the microphone over to Professor Folds.
All right. It's great to be here. So this first presentation is on fairness and bias in machine learning artificial intelligence systems. All right. So let's make sure we're on the same page. I want to briefly talk about what machine learning is. So we are becoming increasingly aware that machine learning algorithms, which make predictions based on data, are making a big impact on our lives. So a common example that we all deal with is credit scoring. So predicting whether you will repay or default on a loan. So on this slide, you have a bit of an example of how this might work. So you have some features for every person. So for example, you could have the number of late payments, the amount of credit used, previous defaults, whether or not you're employed, and so on. And then based on these features, you try to make a prediction. In this case, whether you will repay your loan or not. So the features, they're called a feature vector or an instance. And then the thing you're trying to predict is called the class label. So you try to predict the class label y given the features x. And so these models are trained using a bunch of these feature vectors, and they try to imitate what's in the data set. And this is called classification. This is an instance of supervised machine learning. So it's supervised because the labels are provided. And so there's growing awareness that biases inherent in these kinds of data sets can lead the behavior of machine learning algorithms to discriminate against certain populations. There's been a number of high-profile papers and books on this subject. So for example, the Executive Office of the previous administration published a report called Big Data, a report on algorithmic systems, opportunity, and civil rights. And this was really a call to arms to researchers in both computer science and law and other disciplines to start thinking about these problems. So they showed a number of more or less hypothetical case studies about how things could go wrong in terms of fairness and bias in machine learning. This book, Weapons of Math Destruction by Cathy O'Neill, considers some of the same problem domains, including housing and employment and credit and criminal justice, and goes into greater detail on a number of case studies. One more book I want to point out is Algorithms of Oppression by Sophia Noble. So she takes an intersectional feminist approach to understanding this problem of bias, and she looks specifically at Google and how Google might, for example, lead to problems of representation. So if you search for the term black woman, what kind of results do you get compared to if you search for white women or white men? So there's also very serious real-world applications where these problems are coming up. So there's a system that's already deployed today called Compass, the Correctional Offender Management Profiling for Alternative Sanctions. This system is used to predict reoffending in the criminal justice system. And it's been accused of being potentially biased. So there was an article by ProPublica, Engman et al. In 2016, and they found that this Compass system tends to more frequently incorrectly predict that black people will reoffend and end up back in the criminal justice pipeline compared to white people. And it found that the opposite happened for white people, that you were more than twice as likely to be incorrectly predicted that you would not reoffend when you actually did if you were a white person under this system. And so these findings have been disputed. At least North Point would like to point out that there's other possible definitions of fairness that this satisfies, but I don't think they dispute the main claims that it does make these types of errors. So let's look at an example to see how this might actually happen. So I'm going to show you an example from a blog post by somebody called Rob Speer, and the blog post is called How to Make a Racist AI Without Really Trying. So he's looking at an application called sentiment analysis. And so if you think of reviews, such as on Amazon or Yelp, where there's a product or a service and you can type up a review and post it online, we'd like to predict whether that review was positive, you said that it was a good product or service, or negative, so you said that was a bad product or service. So that's a sentiment label we would like to predict, positive or negative. And so once again, you have feature vectors, and you would like to predict the class label. The standard way to do this these days is to use something called a word embedding, which automatically learns for every word in the dictionary a feature vector. And then given those feature vectors for the words, we can try to predict the class label, positive or negative. And so in this blog post, Rob Speer tried to do this, and he found that the system, just taking this very standard approach, turned out to be horribly biased. So you can look at the sentiment that the model predicts for stereotypically black names, and it finds that the sentiment for those names is on average substantially negative. Whereas if you look at the sentiment associated with stereotypically white names, then the sentiment is extremely positive. And the sentiment for Arab and Hispanic names is somewhere in between. It's not as high as for white names. Here's another example. So Reuters recently reported that Amazon was trying to build an internal tool for recruiting where they would like to predict, should we hire this person or not? And they found that this system was biased against women. So it seems likely that some of the same problems were the cause of these issues, that basically whatever was in the data is somewhat discriminatory. For example, if you try to predict whether you'll hire a person or not, and then you've mostly hired males in the past, then the system is just going to encode that. So where does this bias come from? So you can look at this article by Barakas and Selps, Big Data's Disparate Impact. I will talk through some of the reasons for bias that they point out. So for one, data encodes societal prejudices. So we've already seen an example of sentiment analysis where if you just take data from the internet, let's say, and people are just saying whatever they want to say, if people are biased, then you use that data, you're going to encode those biases. Data also encodes societal advantages and disadvantages. So if certain groups have performed poorly in the past, then the model is just going to learn that. We also have, by definition, less data for minorities. This could make a classifier less accurate for minority groups. And how you collect the data, this can also be a problem. So if you imagine we only collect data from smartphones, then you only have data on people who have smartphones. So you're going to ignore, homeless people, for example, or people who can't afford a cell phone. This has always been a problem in the past with polling. So if you do a phone poll, then you only find people who have a phone in their home. In the early days of polling, that was a problem because it meant that these were the wealthy people, the people who could afford a phone. But nowadays, most people don't even have a landline, and so you're getting a different demographic if you're polling people who have landline phones. You can also get cases of intentional prejudice. This is sometimes called digital redlining. And to hide that process, this is called masking. So there was a case of St. George's Hospital Medical School. This was in, I think, the late 70s, early 80s when this happened. They encoded what they believed was their own existing process for determining whether they would accept a person into their residency program, and they made that system specifically biased against women and minorities. So I think the people making those hiring decisions thought we shouldn't hire women because maybe they're going to get pregnant or leave, so we just won't hire them. And so they just deliberately encoded that into their system. And so it gets more complicated even if you don't try to deliberately encode prejudice in your system, because every variable in your system, all of your features and your feature vectors, are correlated with your protected attributes like gender and race and age. That affects almost everything else about you. And so even if you leave those variables out, then you will, by correlation, still learn some of those same patterns. So what do we do when we decide to model fairness in an artificial intelligence context? So this is very difficult to do. How do we nail down what is fairness? Fairness it's a complicated socio-technical, political, legal construct, and nobody quite knows what it means. But here's some considerations you might think about. We might want to distinguish between harms of representation versus harms of outcome. So in that sentiment analysis system, a harm of representation is where we see that the system is biased against African Americans. And so in that case, you may be offended by that. You may be upset that that's how you're being represented by the system. But on the other hand, this may actually affect an outcome that happens to you. So if I use those same sentiment classifications, or indeed the features that derive them, then I may downweight your CV if you're applying for a job. There's differences between equality and fairness. So if we try to define fairness as everything is equal for all groups, then we can run into trouble if the groups are actually different. We have to decide whether to model differences between populations or not. Should we treat these as legitimate, or should we encode them? And whether to aim to correct biases in society as well as the biases in data. So you want to do something like affirmative action. So a related problem is explainability and transparency. So many of these algorithms are essentially inscrutable black boxes. So it's often very hard to know what these methods are doing. And so sometimes there are legal reasons why you have to provide some kind of explanation with these systems. For example, credit scoring in the United States. And then there's the GDPR protections in the European Union. The law does have some things to say about it other than that. For example, we can just look to Title VII and other anti-discrimination laws, which prohibit employers and other parties from intentional discrimination along lines of gender, race, national origin, and religion. And the basic guidelines for this look at the ratios of probabilities of positive outcome, like hiring a person. And so if I hire all white people, then if I hire black people at less than 80% of that rate, then the law says that is an example of discrimination. The machine learning community has also tried to deal with these problems. So there's been an explosion of research. It's been going on for at least since 2012, but really it's received a lot of attention since around 2016. So there have been cropping up new publication venues that are dedicated to fairness and to related issues. There's the FAT-ML workshop, Fairness, Accountability, and Transparency in ML. The spin-off ACM conference, FAT-STAR. And then there's a AAAI ACM conference on AI ethics in society has also happened in the last 2 years. And in these research communities, there's been a lot of work on defining fairness and algorithms that try to enforce and to measure fairness. The fairness can also be related to privacy, which is another concern of the FTC. So, for example, if I have a system which assigns outcomes to people, like a classifier, it may be possible, based on those classifications, to determine which group you belong to. Are you a white male or and so on. And if that's the case, then maybe even if our system was fair, then somebody could use that to discriminate later on. For example, they could undo the fairness correction that you've carefully done on your system. So this is called the untrusted vendor scenario, due to Dvork et al. 2012. I'd also like to point out that fairness should be related to the study of fairness in society, which has long been studied in the literature on feminism, and especially intersectional feminism. And so intersectional feminism makes the argument that systems of oppression built into society lead to systemic disadvantages along intersecting dimensions, including gender, race, nationality, sexual orientation, and so on. And so the argument is that if you are a disabled Native American female, you're going to have a very different experience than an able-bodied white male. And so, of course, that can be encoded in data, and that can lead to problems. Now, there's a competing notion of fairness called inframarginality, which just argues that different groups do have different distributions over everything that happens to them, all of their features, and so perhaps we should define fairness not as equality, but as the extent to which a system biases above and beyond what is in society. So in my research, I proposed a definition of fairness which tries to look at both the privacy aspect of fairness and intersectionality, and it's also related to fairness in the law, this 80% rule, where discrimination occurs when more than 80% difference between the groups. So it has privacy and economic guarantees, it implements intersectionality, and essentially it's an extension of the 80% rule, but it allows a sliding scale, and it protects multiple protected attributes, and it provides a privacy interpretation. So that's it. Here's my contact details if you'd like to reach out to me. I have a publicly available preprint of my work, and another preprint is coming online soon. So thank you.
Hello. My name is Mark McCarthy. I'm hoping that this clicker works.
Green button.
There we go. Thank you. So I'm going to talk a little bit today about some of the principles that my trade association, SIIA, has put together. But I want to start off by saying we're not alone in this endeavor. The Belmont principles, which many of you are familiar with, the principles of respect for persons, beneficence, and justice, were developed 30, 40 years ago, and they form the basis for the guidelines for human experimentation and the IRB rules that many of you are familiar with from an academic context. The FAT-ML principles that were just referred to are out there as well. ACM has a new code of professional conduct for their members, for software professionals, and our principles are in the same ballpark. There are two others that I want to mention, both of which have to do with human rights. A group up at the Berkman Center at Harvard has put together a series of very good applications of human rights to some of these ethical principles and to hard cases. And Access Now has a similar document where they talk about the importance of human rights in the context of AI. So we're not alone in this endeavor. Our principles are not original. You've probably seen these concepts before. But before I get into them, I want to say a word or two about when to apply these principles, because after all, businesses are engaged in lots of different practices, and it may not always be important to think about them from an ethical point of view. And so the way I'd sort of set it up is when the effect of a business policy or procedure has large effects on these values, these principles, then it's important to pay enough attention to do an ethical analysis. And that's either positive or negative. If there's a huge infringement on human rights, you've got to pay attention to that. If on the other hand, your policy or practice increases respect for human rights, provides increased freedom of speech or increased safety or further health care, then that's also something that should be taken into consideration. It's not just the negative stuff that you want to pay attention to. So that's one. The second point is that what's the status of these principles? How should we think about them? And there's a continuum here from the kind of ACM principles, which are really guides to individual behavior, a code of professional responsibility, and then it extends through guides to companies or self-regulatory principles that might be enforced by a group like the Digital Marketing Association. And finally, soft law, like the OECD principles that were set up on fair information practices that eventually became law in the European Union in 1995. And then finally, law itself. I think we should think of these principles as guide for company action and not go farther down the continuum. And part of the reason for that is most of these principles are very, very abstract. And the key issues are really in the application of these principles, not so much in the articulation of them. And next steps really aren't to further refine or provide more detail on these principles, but it's to apply them to particular cases. And that's where we'll find all the interesting ethical issues. So for example, if you want to talk about autonomous cars, the ethical issues involved are much different from the ethical issues involved in autonomous weapons. In the one case, you may need to solve the trolley problem, but at least assign responsibility to people when something goes wrong. In the other case, you may not even want to deploy autonomous weapons unless you can figure out who's responsible when a killer robot goes amok. And so these are very, very different kinds of ways of thinking about it. In other circumstances, the companies disagree about how to apply these kinds of principles. So I don't think they're ready to go beyond just guides for company action at this point. So let's get into it with that as the background. Human rights. The idea is that when you're engaged in various data practices, collecting data, analyzing data, constructing models, you have to respect internationally recognized principles of human rights. And the sort of ethical thought behind that is your behavior has to really respect the dignity and autonomy of individuals. And you want to not do that in the abstract, but refer to the documents, the guiding documents that have governed international law for a couple of generations now. And so which rights are we talking about? Here's a sample from those international instruments: the right to life, privacy, religion, property, freedom of thought, and due process. And I think organizations really should be bound to validate those internationally recognized aspects of human rights law. Justice. Here the real question is distribution. You start off with the principle that individual people have a right to a fair share of the benefits and burdens of social life. And you want to really be in a position where you're not engaging in data practices that disproportionately disadvantage vulnerable groups. In particular, you don't want your data practices to result in applications that are not available to all and are sort of intentionally or even inadvertently restricted based on arbitrary and irrelevant characteristics, which are race, ethnicity and gender or religion. The organization shouldn't be totally indifferent to how their goods and services that are produced are distributed. It should be a matter of concern for them who benefits from their new analytical services and products. But that brings us to the important topic of welfare. The whole goal of creating these new processes and services is to increase human welfare. And to the extent that you can do that through the provision of public services or low-cost and high-quality goods and services, you have an ethical obligation to do so. The last grouping is maybe a little unfamiliar. It's one of the standard ethical theories. It's called virtue ethics. But the idea is that you want your products and services to contribute in some fashion to human flourishing. And this means that you're really trying to help people individually and collectively to be the kind of people who live well together in communities. And many of these concepts are sort of old-fashioned. The words that are used to describe this set of ethical obligations are honesty, courage, moderation, self-control, and the like. But we all recognize that sometimes business practices can discourage the development of those virtues. And all of the attention to things like the addictive nature of some of the internet activities leads you to think that maybe these devices are teaching less in the way of honesty, courage, moderation, and so on, and are more taking advantage of people's weaknesses. So virtues are a very important thing to pay attention to. In many discussions, these four different perspectives are thought of as sort of alternatives. Pick one. Do you want to do justice, or do you want to do rights, or do you want to do welfare? Which is it? Our suggestion is try to do all. Treat them as a kind of checklist and a set of guidelines to go through as you're considering what needs to be done. But the real issues here, and this is to repeat a point, arise in specific domains. And I think it's important to see how these principles are applied in practice, because that's where the key ethical issues will really come to the fore. So to talk about one that was raised before, disparate impact analysis, as was mentioned, a key part of assessing algorithms is to make sure that they comply with the various statutory requirements, including the prohibitions on discrimination. There are three stages of a disparate impact analysis. The first is you've got to take a look and see if your algorithms are having a disproportionate adverse impact on people. You have to see if there's a legitimate purpose that's being served by this. And then the third step is you've got to take a look and see if there are alternatives that would have the same effect on your potential purpose without having that disparate impact on vulnerable people. Three different areas to think about. Which groups to assess? The protected classes include race, gender, religion, and ethnicity. One of the things that we encourage our members to think about is expanding to vulnerable groups that are also at risk but are not explicitly protected by law. And which purposes to assess. The law right now protects eligibility decisions in employment, housing, insurance, and credit. But there may be other areas that are not covered by existing laws where the decision-making is consequential for people's lives, and companies should be thinking about whether or not to have the same kind of disparate impact assessment in those contexts. So there's a lot more to talk about. I'm delighted to be here at this panel. Thank you for having me, and I look forward to the conversation that follows.
Can you get around me?
Thank you. My name is Dr. Aman Chowdhury, and I'm the Global Lead for Responsible AI at Accenture. And I'm going to be talking a bit about understanding algorithmic bias, particularly with a focus on consumer harms. Much of our narrative today is about primary harms, how do we expand and understand the conversation about secondary harms, and what are these secondary consumer harms that we might want to think about? But first, as a bit of background into our practice, I have a co-lead, Deb Santiago, sitting in this audience today. We lead our responsible AI practice at Accenture. We want to understand the social, regulatory, and economic impact of this technology from development to deployment. We do provide solutions for clients, but we're very active in the responsible AI community, including groups such as the IEEE, World Economic Forum, Royal Society of the Arts, etc. So we take not only a US perspective, but also a global perspective, industry, government, and citizens. So just to take a step back and think about why we need ethics. This space is actually very, very new, and this panel is very representative of how very new this space is. We have researchers developing research at the same time that practitioners such as myself are deploying these solutions to clients. And that's pretty rare. So our pipeline needs to be very short, but at the same time, we need to be very, very careful about what we're building and how we're thinking about it. Most of my time, when I first started my job in 2017, was spent building awareness. What is responsible AI? The words we use today, we didn't even have over a year ago. The way we refer to things, the language that we're using, this evolution of the space to think beyond technological tools to now an evolved conversation about the human rights impact. This is all happening at the pace at which you're seeing it right now. 2018 was a year of action, so Accenture was first to market with a fairness tool. But my colleagues before me alluded to these concepts of fairness. Our tool is grounded in legal precedents, so we have a disparate impact component to our tool, and we specifically think about the impact of the pipeline between the legal and regulatory space to how we're applying this in our solutions. And finally, what we're thinking about moving ahead is this concept of agency and accountability, which is why I'm here today, which is why the FTC is considering artificial intelligence, ethical frameworks, and how it impacts consumers. What we have found from a technical perspective is we can't solve all the problems, and maybe this is obvious to the people in this room, but this is not obvious to Silicon Valley, that we could not solve all the problems by pushing buttons, writing code, and fixing our data. What we realized, and the Amazon HR example that Jimmy pointed out is a very good example, that's actually, in my opinion, an example of good governance. They tested a product, they innovated safely, but they actually found that it was an intractable human problem. Their hiring practices were unfair. That is not a data solve, and they tried for years to make a data solve. But ultimately the question becomes, well, Amazon, now that you have this information, what will you do with it? And that is where the systems of agency and accountability come in. Thinking on a more granular level, if an individual algorithm has a negative outcome, then who is responsible for identifying what that harm is and addressing and redressing that harms? As citizens and as consumers of this technology, who do I go to if the Amazon recognition system falsely identifies me as a pickpocketer? I know what to do if there is, for example, a biased police officer. We have systems of addressing and redressing these problems, however we may feel about them. We do not have an infrastructure of addressing and redressing the harms that are done to people by artificial intelligence. So to think a bit about what is bias, Jimmy did a really great job of identifying from almost a technologist perspective what is bias. So we think of bias as a quantifiable value. As a social scientist, I would often call these experimental bias. So things like sentiment analysis, things like imperfect data. But really the takeaway here is that for us, often when we think of bias, it is a measurable value and often something you can fix if you just throw enough data at it. If you fix your data, you clean your data, you bootstrap your data, we will be able to fix this bias. Or if we change our model, change some parameter, we are endlessly tweaking and changing to address this kind of bias. However, when non-technologists talk about data, often we talk about this societal bias, and these 4 harms that I've listed were developed by the Future Privacy Forum, and I think they encompass the kinds of primary harms that we talk about today: economic loss, loss of opportunity, social detriment, and loss of liberty. Things like the Compass algorithm, denying people parole unfairly. So this is a loss of liberty. But when we think about bias, we're also often thinking about primary harms. So being specifically denied a job when I'm of a protected class is something that is illegal. Now, if we could define all of the harms neatly into those kinds of buckets, frankly, we wouldn't be holding this panel today because existing law would be more than sufficient to address all the harms that are happening, or at least the implementation of existing law. Instead, I want us to think about secondary harms. So this concept I'm calling algorithmic determinism. And one thing I want to point at as a good example of algorithmic determinism is the filter bubble. Now, what's interesting is we have been talking about the filter bubble for over a decade. We've been living in the filter bubble for more than a decade. The book, The Filter Bubble, was published in 2008. So the question today is, does the filter bubble lead to ideological polarization? And if you're unfamiliar with the concept, a filter bubble is when a recommendation system, an algorithm built by a search engine provider or a media outlet, is curating data based on how you are reading information. So what is the incentive of a media company? It's to give you things that you will click on and read. But what happens as a result is ideologically, you start to live in an information bubble. You have no idea or concept of what other people are talking about that is different from your notions and your ideas. Why is this dangerous? The way these algorithms will work often is they will increasingly polarize you towards the opposite end of the people. You're moving away towards the center. And there's two reasons this is very dangerous. Number one is the obvious one, because I don't know what is happening in the world. And I think that I am always right. But I think the most dangerous one, number two, is that if someone were to come to me as a human being and say, I actually think a totally different thing from you, I would actually just think they're crazy, as in you have no grounding, all the science backs me, because that is all I know and all I see. And that inability to communicate on equal ground is really dangerous. So, but what I will add to this narrative is important because it's not as if we as consumers are battling this. We welcome this. Confirmation bias is a very real thing. We love being right. We love having our opinions affirmed. And what happens here is often we are battling our own inner biases, our desire to be right. We don't like it when we're wrong. We don't like if somebody challenges us. So we're not just battling an algorithm trying to guide us in a particular way. We are also battling our own nature. So another example, and this is an example which starts to get into secondary harms, right? There is nothing actually illegal about Netflix targeting users by race. So why are we so upset about it? Why do we think there is a problem with Black people being shown images of Black people and women being shown, movies with a strong female lead, which is often what I will get in my Netflix queue? But we know that there is something wrong, otherwise this would not be headlining in the New York Times. And because, as I mentioned, we don't yet have the language in the responsible AI community for many of these things, I invite the term algorithmic determinism to think through these secondary harms. Why are we so worried about it? Because we are worried about a world in which we only identify ourselves by our race, we only identify with people who are of the same race, and we're only interested in media that looks exactly like me all the time. What that does is reduce our ability to be empathetic towards other people and other people's life situations. So from a quantitative perspective, algorithmic determinism is a measurement bias plus a feedback loop. So a measurement bias ties into what people like myself do, which is literally the data bias. And a feedback loop is an engineered loop where your output starts to influence your input. If we think about artificial intelligence as an algorithm that learns from its environment, well, if I put something out there and I assume something about the world, and then by doing so, I make the thing happen, and then I use that data to feed back into my algorithm, I'm creating a self-reinforcing hypothesis. So algorithmic determinism starts to not only make wrong assumptions, that's only half of it. The other half is it creates the world in which the wrong assumptions are now true. So measurement bias, as I mentioned, what you think you are measuring is not what you are actually measuring. And a feedback loop is a structure that causes an output to eventually influence its own input. So just in conclusion, I invite a conversation around different types of bias. So what does bias mean to different parties? As technologists and non-technologists try to bridge a gap between our lexicon, let's make sure we're on the same page about what we mean. And second is that, as I mentioned, humbly speaking as somebody in the responsible AI community, we are still building our own lexicon, our own language. Our language of harms needs to evolve to embrace algorithmic determinism and the effects of secondary harms. And agencies and bodies like the FTC, who are dedicated to protecting consumers, can also be involved in this conversation and thinking about not just the primary harms, the direct harms to people being denied services, but what are the long-term impacts to society that may happen as a result of algorithmic determinism. Thank you.
All right, thank you very much. Thanks to the FTC for having me here. I'm delighted this conversation is taking place, and thanks to the other panelists. So I lead a group, co-lead a group at Google called the People Plus AI Research Initiative. Our goal is to make human-AI interaction better, to make it more productive, enjoyable, and fair. And we take a broad view of this mission. For one thing, we're interested in all types of people, whether consumers, people who are professionals like doctors using AI, or engineers or other developers of systems. We think it's important to think about how all of these people work with AI. We also produce a wide variety of work, from fundamental research that we write up in academic publications, educational material, but we also do engineering. We build tools, and those tools, the main subject of what I'm going to talk about today. So why are we building tools? Well, let me take a step back and talk a little bit about Google's AI principles. You can see them here. These are principles that sort of guide us internally, and externally we see as a kind of stake in the ground. Some of these in particular, I think technology can actually help with. You know, we've heard today that technology is not all of the solution, but technology certainly has a role to play in making things better. In particular, as we seek to avoid bias or avoid reinforcing existing bias, create safe and accountable systems, and just uphold good standards of excellence, tools can be very useful. And I want to talk about a suite of tools that we've released to the open source world. These all have a theme, and the theme is helping humans understand AI. For us, we feel like the root of the best path to moving forward is to increase our knowledge of what's going on with AI systems. You know, it's important, I think, both from an engineering perspective and to make sure ethically that we're doing the right thing. You hear a lot that people use the phrase black box in talking about machine learning, and it's not wrong in the sense that it can be difficult to understand certain types of models. The field is moving quickly. However, I think it's inaccurate, and that there are often many ways that we can actually get a handle on what's going on in systems and then use that knowledge to make improvements. One very important point I'd like to make is that people often talk about transparency as a key value. And transparency really has a lot of different meanings here. It's not only as useful to get full knowledge of a system. I mean, just to give it a kind of silly example, it's like, if I wave my hand like this, why did I do this? One answer would involve every state of every neuron in my brain, not very useful. Or the answer might be to make a rhetorical point, which is useful. Similarly, when you think about AI systems, there are cases where an engineer might need a whole lot of detail to debug a particular issue, but there are cases where a consumer might be overwhelmed by a lot of detail and might need just the type of information they want to make a particular decision or perhaps contest a decision. Okay, so given that this type of knowledge of an understanding of AI systems is important, what can we do to help with that? So one issue is to think about the data that these systems have been trained on. So as we've heard, training data is sort of a key part of any machine learning model. It really determines the behavior. In fact, arguably, that's the definition of machine learning, is that the training data does determine the behavior. So in order to understand what a system is doing, it means we need to understand something about the data very often. Now, this is hard because we're dealing often with a lot of data, very complicated data, and generally speaking, people are not incredibly good at sorting through data unless they have a lot of expert training. Just looking at a huge table of numbers is overwhelming for almost everyone. But here's a place where technology can help. One approach that my group takes to some of these problems is with data visualization. So one tool that we've released is called Facets. And the idea here, you can see sort of an animation up here, shows this tool in action, is that it lets you slice and dice this data set in various ways. You can look at quite a lot of data points. You can divide them into groups. You can divide them into subgroups. One way to look at it using language we've heard today is this is a tool for understanding intersectionality, that we can actually see how different groups interact with each other inside of the data. And often using a tool like this, you can, as a human, start to get a sense of what's going on, what might be driving an issue with your data, what might be potentially an issue that you haven't seen yet in behavior. So this is one very important way that we can start to get at what's going on. Okay, so data is one aspect. What about a model itself? Very often, if you have a machine learning model you're trying to analyze, you want to ask it questions. You want to know things like, okay, so I understand how it does on the training data. What if I gave it something that was completely different from anything in the training data set? How would that affect things? Or say it's a classifier, and it classifies a data point in a certain direction. You might say, what would change that classification? You might want to fiddle with particular aspects of that data point, or ask, what is the most similar thing that was classified differently? So these are natural questions, and I think anyone working with machine learning is familiar with this kind of thing. The problem is that they typically require programming. It requires engineering time to do this. That means that stakeholders, people who are not fluent in programming languages, may have a harder time getting answers to these questions. So an approach that our group at Google has taken is to create a tool that lets people do this without coding. This is something we call the what if tool. And it's designed exactly to take a machine learning model in and then let you pose to it hypothetical questions. And you can see sort of an animation walking you through a little bit of what's going on there. It's built, Facets is that visualization we just showed is part of how this works. And it's a kind of a Swiss Army knife for understanding what's going on in a model. Now, there's something else. In addition to looking at what's happening with an individual data point, we can calculate more global statistics. And this has a lot of helpful uses. One is for thinking about fairness. One thing we can do is if you define particular groups, then you can sort of look at various group-based fairness measures. Now, as we heard earlier, there are actually many different mathematical measures of fairness, and I think sorting through these is an important issue for the community. We don't take a position on this, but we do offer people the option of saying, okay, I'd like to measure my system in various ways. We go one step further then, which is to say, if you have a threshold-based classifier, something very common, then we can do a little optimization and say, if it is not fair according to this particular criterion, how would you change the threshold to make it fair, or as fair as possible? So this gives you actual actionable feedback that you could use with your system. Now again, I want to emphasize that as we've heard so far, fairness is a very deeply complicated socio-technical issue, and in no way do we claim that just tweaking a threshold is going to fix every problem. But it's something that can be an important part both of understanding a system and thinking through ways that will lead to a solution. I want to end with one other technology that our group has developed, and this is for looking at neural networks. So 95% of the time that you hear people talk about machine learning systems being black boxes, they're talking about what are called deep neural networks. And the truth is that these networks are complicated. They're typically specified by several very large matrices filled with numbers that can look random at first glance. So they can be difficult to analyze. They're also often used on data sets that themselves are difficult to understand. A classic example would be image recognition. Suppose you have a system that is designed to recognize whether an image is a zebra or not. It's looking at individual pixels, and a lot of classical methods will tell you things like, okay, did this particular pixel make a difference to the classification? Did that particular pixel make a difference? It's not super useful looking at individual pixels. Instead, you really want to look at something like, did stripes make a difference? the method that we've used is something called TCAV. It stands for Testing with Concept Activation Vectors, and this is introduced in a recent paper by Bean Kim and others. It's released as an open source tool as well. And what it does is it uses machine learning to help you understand machine learning. After something is trained, you can give it examples of a concept you're interested in. For example, for stripes, you might give it, say 20 examples of striped rugs or shirts or whatever. And then you can ask it questions. How sensitive was that zebra classification to the concept of stripes? And so this is, I think, a very good example of the type of translucency that's helpful. We're not giving a researcher or a person looking at the network the full matrix of every weight in the neural network, but we're giving them information that's useful at the level that they want in terms of a concept that they're actually interested in. So I'd like to end there, but the point I'd like to emphasize is that there are many ways in development we're making real progress in coming up with ways to understand these systems, and I think they no longer need to be considered black boxes.
Good afternoon, everyone. My name is Erica Brownlee, and I'm at MasterCard. It is a pleasure to be here, and when I say here, I don't just mean Howard University Law School, but at the participating at the FTC's hearing on competition and consumer protection. As a former FTC person, I spent about 10 years at the Commission in roles on the competition side and the consumer protection side. And so I appreciate the opportunity to be able to participate in hearings that are covering both sides of the Commission's mission. Say that 5 times fast. But before sharing my perspective with you on AI, I thought I would turn back the clock a bit. Not too much, but just for a few years, when you think about, and some of you in this room might actually be familiar with AI from the concept of a movie that was released some time ago called War Games. And when you think about that movie, there was a computer named Joshua who had to actually learn and self-teach so that it would prevent nuclear war. Well, that movie could have been made credibly in 2018, but it was actually released back in 1982. And so, of course, back then, artificial intelligence was a lot more aspirational. But due in part to the computational power, the increase in computational power you've heard from not only this panel, but earlier in the day, and access to available data, we now use it as artificial intelligence as part of our daily lives. And the last panel talked about examples of that, of the innovation behind AI powering healthcare, to detailed subway maps, to computer vision. But the agility of AI really presents these opportunities for innovation. And at MasterCard, we use artificial intelligence for fraud protection to make our payment system safer and more secure for cardholders. But as I think you've heard from my colleagues on the panel, there are some opportunities also for some structure around the discussion of ethics in the deployment of AI. So ethics is somewhat of a diffuse concept, just like fairness. It may mean different things to different stakeholders, but several themes have emerged to form a common set of principles. And I wanted to cover a few of those principles today, including transparency, accountability, and privacy by design. And I'll start with transparency because of its role in building and maintaining consumer trust, which is a key part of the ethics equation. Consumers need to trust, need to have trust to be able to want to share their data and have confidence that in sharing their data with entities. And so openness is a part of the process for gaining and securing and maintaining that trust, and it can facilitate that confidence. But by openness, I'm not referring to the publication of algorithms. Martin just talked about the deep neural networks or source codes. From a consumer perspective, I'm not sure how meaningful they would find them. A few months ago, Harvard Business Review published an article that about a case study involving a Stanford professor, Clifford Ness, who faced a student revolt. What happened? Well, the students in his class claimed that the professor's teaching assistants were grading the same type of material in different ways. And so on their final exams, they were getting disparate grades. Turns out they were right. And the professor agreed with that there was a disparate outcome. And so as a computer scientist, he designed a technical fix and built a model to adjust the scores. And in the spirit of transparency, he provided by email the full algorithm, and so to the students. But the result was that the students were actually more angry, and there were more complaints. And so it was hard to reconcile this level of transparency. So 2 years after the student protest, another professor's student decided to do a study to explain what happened. And in that study, the students were provided different levels of transparency about the grades they received on an essay. And it turned out that while medium transparency increased trust significantly, high transparency actually eroded the trust completely. And so the derived conclusion was that users did not necessarily trust black boxes, you've heard a lot about those, but that they didn't, and that they didn't really necessarily need or want full transparency, but actually enough information about the basic insights and the factors driving the decisions that were based on the algorithm. But context matters. So the idea of transparency varies depending on the context. And so if, for example, if there's a smart washing machine, the explanation of the decisions behind how to get your clothes clean are quite different in need from decisions about credit scoring or learning or lending, for example. So there's a difference in terms of context. The other aspect of the other principle I wanted to cover is accountability. And accountability carries forward that level of trust and confidence of consumers. But there are several different levels of accountability. At a macro level, accountability can show how AI systems or models are ethically used to create social value. At a more micro level, accountability involves reviewing and assessing those established objectives of an AI system. And we talked about some of those, or you've heard some of those ways in which, from a technical perspective, you can accomplish that. But by documenting the review and assessment, it can provide a means of creating that feedback loop that can help in understanding ongoing performance and identify some of those anomalies and perhaps unintended consequences that Jimmy was talking about earlier. Accountability also provides oversight of the technical administrative controls. We're all familiar with audit, an audit, for example, of access controls. But given the substantial increase of data that is collected by an AI system, those technical controls become even more important. So the last principle or theme that I wanted to talk about is privacy by design. And an important part of the exercise, really, of using an AI system is to reconcile the tension between the protection of individual privacy and the benefits from facilitating that access to data that I was just talking about, that AI needs to be innovative and to work efficiently. Privacy by design can reconcile those two competing interests. So by embedding privacy into all of the stages of development, and so from that I mean from design, well, really from ideation, then design, build, testing, deployment, privacy can actually be used as a strategic asset. So, for example, the concept in privacy, it's one of the key concepts is minimization, which calls for limiting the amount of data that is collected. That may at first seem to be contrary to how AI systems work and what I was just talking about in terms of availability of data. Well, at a certain point, an AI system may actually not benefit from the increased value or the increased amount of data. In other words, that it's not necessarily improving the success or efficiency of the result. And so limiting data may improve efficiency. Or it may be that data becomes less relevant. And so over time, that may also encourage minimization. Privacy by design, we heard a little bit about that. The legal requirements, data flows across borders. So even though we are contemplating more of a US perspective here, it's important to consider from a global perspective as well, because other jurisdictions have, in fact, restricted and added additional requirements with regard to transparency or consent from the individual to use their data. And a privacy impact assessment can be used to identify those potential risks and harms to individual privacy and strategies for managing those risks. The idea is that if you incorporate privacy, and in particular, and again, it's not sort of a one-size-fits-all, but incorporated appropriately, it can enhance the AI profile. One other point I wanted to make before concluding is just about data literacy, which is something that goes hand in hand with privacy. It's part of the broad theme of accountability, because data literacy extends from the ideation stage and with the computer scientists and coders all the way through launch of a product. But I'll conclude by saying that as we go forward, it's important to have standards that are consistent, standards that are flexible and interoperable, not just in the US, but globally, and that ensure meaningful protections of privacy. So I'll stop there and turn it over to Naomi. Thanks.
Okay, thank you, and thank you for having me here today. It's a pleasure. So I'm going to talk a little bit about sort of the research and standards space, and also a little bit about where Nist is trying to contribute to some foundational concepts in privacy, risk management, and engineering, and see how they might apply in the AI space. So at Nist today, we have about more than 50 projects that are either contemplated or underway in artificial intelligence and machine learning. And many of these are focused on exploring fundamental questions related to measurement and quantification. And I do not have even barely the time, I don't have any time, right, in 10 minutes to talk about all of these projects. So I really just want to make this sort of a key point that you've sort of heard that, we have to understand, what kind of assurance we can get about the sort of the correct operations of AI systems. And I think you've already heard today that even correct, right, is a sort of a complicated concept. And has different viewpoints on that. But at a bare minimum, right, if we want to have AI systems adhere to ethical frameworks, we really need to understand what that correct operation means in that context. Otherwise, we really don't know if they're going to adhere to them. So the next set of slides I am going to run through. I'm not going to talk to these individually. What I really just want to share with you, and I know that I understand these slides will be posted so that you can look at this and get a better sense if you're really interested into where the sort of scope of work is going around various standards. And so the second point I want to make is that these aren't actually finished standards. Nothing that I'm going to show you in the next set of slides. You'll see study, you'll see all kinds of terms, but none of them are completed standards. This is beginning work. But why do standards matter? Let me give one example, not in the AI space. So we were working in the identity federation space and wanted to see more privacy-enhancing technologies integrated. And what we quickly discovered was that the underlying protocols on which sort of identity federation is running had never contemplated some of the integration that we wanted to do. And literally in terms of sort of like, hey, we want to put this key exchange in here for this privacy enhancing cryptographic technique, and there was no field for that in the protocol. So people don't like it when you break protocols, when you break standards, because the point is everyone is trying to build their systems to use these standards so that everybody can communicate interoperably. And so it's actually very important to build in some of these, what you want out of a system, either from ethics or privacy, into these standards, or be thinking about that, because if they get designed, if these sort of underlying standards get designed without that, it's very hard to go back. You can go back and redo the standard, but it's very hard to get your additional technologies sort of retrofitted in there. And then the other point that I want to sort of make is some of the challenges in the standard space. And so you can see that there's these different types of standards. Some of them are very specific, like a standard for ethically driven nudging for robotic intelligence and autonomous systems. But you see over here in ISO, they've got all these different working groups. That's what WG stands for. And you can see, so for example, in SG1, right, there's that computational approaches and characteristics of artificial intelligence systems. If those, if you're not thinking about sort of those ethical characteristics, and people in there are not thinking about it, the ones who are actually building that standard, it's not going to get done. And so it really takes engagement, and you can see there's these multiple groups, and they're all working on these different areas. And they do try to have liaisons, but it is challenging and something to be aware of, and why Nist encourages everyone who can to get engaged in standards development, so they get developed the way we think they should. So I'm going to move on, and you can look at these. And now I'm going to talk a little bit about some of the Nist work. So we introduced some concepts, some constructs around privacy engineering and risk management because we saw some of the same issues that are coming up. What do you do with principles that are sort of this high level, and how do you deal with them down at the implementation stage? And so, I will admittedly say that we are using the term privacy, but it's a imperfect word, and you'll see that I think we cover a lot of the things that people are talking about, which might in some people's minds go beyond the concept of what they think of as privacy. The main point here is that first we began to have, we have some of the same issues like lexicon and language. What are we talking about? Maybe people think that, okay, if I'm protected data, I've managed privacy. But of course, there's more to than that. And sometimes we talk about an example with the smart grid, right? So the reasons that some communities were objecting to smart meters wasn't so much because the utilities couldn't keep the information secure, but because the smart meters were collecting such detailed information that inferences could be made about their behavior inside their home. And so how do we manage some of those? Well, in security, right, when we want to understand how do we deal with implementation, right? I mean, how do we go from principles and how do we apply them? We tend to use a security risk model. And so here, I think everybody knows there's a, what's the likelihood that a threat can exploit a vulnerability and what's the impact? But how do we apply that in the smart grid space? What's the unauthorized activity that's happening? What's the threat? The smart meter? So we had some concerns that that was not necessarily the greatest model for the full scope of privacy risks. And so what we said was, what's the adverse event? And what are some of the things that you've been hearing about? We've heard it in different terms, secondary harms, primary harms. We went with the term problems to sort of distinguish from things that might be legally cognizable versus things that are going to be, troublesome for people, and that organizations may want to manage regardless of whether there's a legal cost to it or not. And so you can see that there's a whole variety of problems. This is non-exhaustive, and you can put sort of anything in there that you want that people can experience. And that allows us to have this model where we can say, what's the likelihood that any kind of processing of data, any particular operation could create some kind of problem for individuals, and what would be the impact. And that's really the heart, right, of where you go from principles to, what people have been, my panelists have been talking about, which is like, well, how do you change the context? How do you understand how much transparency to have, right? Well, when we can think about sort of the impact and we think about, hey, what do I want this AI to be doing and how do we want it to impact or not impact individuals, this is where a risk model and risk management processes can come into play. And the final thing that I would just briefly mention is the other construct that we introduced in our Nist report is the concept of privacy engineering objectives. And these are essentially additive to the security objectives, confidentiality, integrity, and availability. And so I think you've heard some of the challenges around things like transparency. They can be interpreted very differently. And so, for example, we can elevate that into, as an objective in terms of what kinds of properties do we want our systems to support. We can say, well, we would like to enable reliable assumptions about processing. And if we extend that to AI, we could extend that to AI behavior. So we don't necessarily need to know every detail, but we'd like to have some, reliable assumptions. How much manageability, right, or intervention, right? If I'm driving a car, I can make a choice to hit a squirrel or, save my child, right? So I can make those choices, and I'll be, I will take the consequences for that. But what about the AI? Do I have any ability to intervene in whatever programming and decision-making it's making about that? And then disassociability is really about being able to disassociate information from individuals and devices. So with that, I will end. Thank you.
Thank you to each of our panelists for the excellent presentations. To start things off for the discussion portion of the panel, I want to remind our panelists to please turn your name cards to the side if you want to weigh in. I want to start off with a fairly broad question. So over the course of the day, we have heard references to a number of different ethics concerns and other constructs related to ethics. For example, we've heard about transparency, accountability, privacy, bias, fairness. My question is, are the ethical concerns raised by artificial intelligence different from the ethical concerns that are raised by traditional computer programming techniques or by human decision making? And if so, how and why? James, do you want to start? Jimmy?
Okay. So first, I would say scale is a big difference. So you can build an AI system and then deploy it on millions of people with a few clicks of a button. So just the sheer scale of potential impact on people, I think that's a big one. Another one is kind of transparency is different versus human decision making. In some sense, everything is there in the computer, right? You have a model or an algorithm that's making decisions, and it's all digitally encoded. But it can be difficult to understand what that means or what it's doing. So Martin was speaking to ways we could try to unpack that, but it is a difficult challenge. Whereas, as Ruman mentioned, if you have a human, you can go and ask them why they made a decision, but we may not be able to do that for algorithms.
Ruman, do you want to go next, please?
Sure. So to echo Jimmy a little bit, I have what I call the 3 I's. AI is immediate, impactful, and invisible. And what that means is when you deploy an artificial intelligence system, it impacts as wide of an audience space as you have. So you think of a social media company making a change to its algorithm to show you media. It happens right away. There isn't, I'm sort of oversimplifying the engineering process here, but there isn't this like wait period where you ramp up. The impact, this is what Jimmy was talking about, you touch people's lives in very meaningful ways with artificial intelligence. And this is different from traditional computer systems and traditional methods of thinking about computation, as opposed to systems like maybe a car or a television, which is sort of tangentially related to our lives. As much as I may love watching Netflix, it's technically tangentially related to my life. The algorithms that influence my life are things that actually are literally impacting my life choices. And finally, they're invisible, so this notion of a lack of transparency, but also the fact that I don't always know when there is an algorithm impacting my experience. I am not sure if I am being shown something because it's been hard-coded or selected for me because there's an algorithm. Now if you think about the notion of bots on social media, those are algorithms posing as human beings. I may think I am being given media or told some information, but I am actually not. It's being curated by an algorithm. So thinking about the difference between AI and traditional computing, specifically with the 3 I's, and importantly about the pervasiveness.
Mark, did you have something to add?
Thanks. Let me emphasize the continuity rather than the discontinuities. Many of the same issues that we run across in the older regression analyses models, the credit scores, the recidivism scores that are so controversial right now, provide very good models for how we should think about the ethical issues involved in machine learning and other AI systems. I think the techniques of explainability, of providing reasons, identifying the major factors that credit scoring companies have been involved in for a generation are useful lessons for AI algorithms as well. You get into a slightly different set of issues when you come to autonomous systems where the activity really can take place without human intervention. Autonomous weapons where you say, pick your mission and then go execute it without human intervention. Those raise ethical issues that are quite different from standard regression analysis, and they deserve different thinking. Same with autonomous cars, to the extent that they're making decisions about what to do on the road without human intervention. Those questions really raise some new issues. But for the most part, in the issues that we deal with on an everyday basis right now, the new systems really are largely similar to the older systems, and many of the principles and many of the techniques for thinking about these problems have been developed for the earlier algorithms and can be applied to the new cases as well.
Martin?
Yeah, I just want to add that I think the focus on ethics is actually really beneficial and is helping us even understand existing systems better and what was good about them. So one example that came up earlier is this idea that if you take a human decision-making system and automate it, you might lose the chance for contestability if you do that in a careless way. And I think what that is telling us is the key issue was the contestability. It's less about automation or not automation, and more about what we want as a society around that process. And I think that's an important thing to keep in mind as we think through these issues. Often we discover, thinking about ethics in the context of AI, we've clarified our thinking about non-AI systems as well.
So I would like to ask a question that's related to the last one in terms of comparing AI to other more traditional methods of analysis. And we've heard a lot of different frameworks and principles for AI, such as the fairness, accountability, and transparency, the Lamont principles, SIIA, IEEE policy standards. So there's a whole lot of frameworks. And by thinking about these different frameworks and applying them to AI, are we holding them to different standards than would be applied to human or other traditional decision making? And also, perhaps a more complex and case-by-case question, but how can compliance with these ethical frameworks or principles be measured, and by whom? Maybe we'll just go down the line again. James, would you like to start?
Right. So first, I want to point out that AI systems are engineered. Right? They're created, even though they're run by mysterious algorithms. They're generally put together by a team of humans who work for a company and who will analyze the performance of these systems and measure what they're doing and to decide if it's satisfactory. And so to that extent, these systems are actually not that different from other complex systems, such as the creation of automobiles. So my view is that we should hold them to similar standards to other complex engineered systems like creating automobiles or airplanes or spaceships and so on. In terms of how to measure these things, so the machine learning community has put together a large number of definitions of fairness and so on. So these are definitely tools that we could try to use to measure if these methods are fair or not, and then we have to probably have a debate about which of them we give the most weight to.
Thank you.
Let me agree with the point that there's a similar set of standards that apply to AI and non-AI systems. I think the principles that I cited are largely usable in many, many different contexts. But that brings me to the measurement question, and I don't think there's a good way to measure compliance with principles at that level of abstraction. All of the key issues really are going to be wound up being faced when you get to the level of application. And there, I think measurement is the wrong concept, because it sounds like if you just add and subtract enough, you'll come up with an equation that gives you the right answer. And in fact, these are very, very complicated and difficult ethical questions. It's not to say there's no right answer, but it may be the kind of answer that emerges from discussion, debate, and reflection on what we want as a society, rather than measuring something and coming up with the right answer. To go back to the concepts of fairness that were developed before, the computer science community knows perfectly well that they're trying to provide sort of computer science analogs of very basic legal, philosophical, and ethical concepts. And they break into two big parts, group fairness versus individual fairness. And people differ in a large part on whether they think fairness is a matter of accuracy in classification and that's it, or whether they think fairness is a matter of protecting the interests of vulnerable groups, including groups that have been historically disadvantaged. And you get very, very different conceptions of what the discrimination laws are all about if you take one of those two different points of view. And then you develop very, very different computer measurements of whether you satisfy those objectives once you bring it down to the level of measurement. But the key concepts are fundamentally ethical, philosophical, and legal, and they're not concepts that are native to computer science.
Oh, I just turned it off. Okay. Yeah, I think that the question is very interesting because it really poses, something that as a community we need to think through in terms of whether how ethics plays out in decisions for AI. There was a commentary from a German parliamentarian when he was asked about the trolley problem, about whether what the result would be if a trolley is going down, for those of you who don't know, if a trolley continues straight, then it and does nothing, then it results in the deaths of everyone. But then if it is diverted, then some people die and others don't, and so sort of that ethical dilemma. And the response was, well, whether it's a human making that decision or an algorithm making that decision is still a tragic result. And so, from a human perspective, it's going to be a split-second determination that no one really has time to think about. And so you could deploy that almost from a randomness perspective for an algorithm and end up getting the same result. But the creepiness of it is that comes from that transparency. And so how is that decision being made? And so my panelists have talked about it comes up a lot more when the higher the impact to the individual. And so I do think it flows back to that level of transparency. But whether it's an AI system or not, levels of transparency and the requirement to provide additional information behind decision making is long embedded in U.S. law. And so I don't know that it necessarily makes a difference whether it's an AI system or not. To me, it comes down to the impact.
So I guess I would say that there's sort of different levels of measurement, and part of that has to do with what are you looking for, right? And so I think that's been underlying a lot of the presentations today. And so one reason that we went in the direction of privacy engineering objectives was because of the fair information practice principles are hard to sort of measure, but you can measure what a reliable assumption is, right? You can actually test that. And so that is one of the reasons why I think, the confidentiality, integrity, and availability have been successful as security objectives. So, because they try to break these things down into pieces that you can then assess. And so I think that's part of this conversation today, and that will go on, is figuring out what are our objectives, and how are we sort of, managing risk, and so what are we looking for, and then we can know what we can measure.
Are there ethical issues that people are raising in relation to artificial intelligence that may be misplaced? And if so, what are some examples?
I think the whole notion that that artificially intelligent systems will develop consciousness and agency, I think is so speculative that it's not a real problem, and yet it's the kind of thing that absorbs a lot of time and attention, far more than it really deserves, considering that there are real problems associated with these systems that need to be fully addressed.
Ruman?
So I used to start all of my talks by saying there are 3 things I don't talk about: Terminator, HAL, and Silicon Valley entrepreneurs saving the world. So I just add that to the mix. But I'd also say that often we over-anthropomorphize artificial intelligence. There is, as humans, we like to impose human features on things. And you think about being a child and your favorite toy, which may have been a bear, but you gave that bear a name and it had a personality, right? Or you had an imaginary friend. That is what we, even as adults, we humans like to do. So one thing that particularly concerns me is a sense of over-responsibility of the algorithm for the negative outputs, term I call moral outsourcing, where by anthropomorphizing the AI and deflecting or pushing all the responsibility on the artificial intelligence by writing this narrative that it is alive, it is making decisions, et cetera, it has free will, we're removing the responsibility from human beings, and we're scaring ourselves away from the narrative and from the ability to fix these very human problems.
Martin?
Yeah, I mean, I think echoing what you've heard, I would say it's not possible to overhype ethics. I think ethics is critical, and this focus is really, really good. It may be possible to overhype AI, that is, as we've heard, I think it's a tool, it's an important tool, and a very exciting one, but in the end, it's a technology like many others we've dealt with, and I think we should deal with it in the same way as we've dealt with other technologies.
So this morning in Michael Kern's presentation, we heard some things about trade-offs between fairness and accuracy, and even trade-offs between different types of fairness. And so I wanted to get this panel's take on those types of trade-offs, and also what are the considerations that should govern the design of the system in which accuracy and fairness are at issue.
We clearly all have very strong opinions.
All right. So, yes, there are definitely trade-offs between accuracy and fairness. Of course, it depends how you define fairness. So there are some definitions of fairness which only consider accuracy as being a good thing, but there's other notions more related to equality or parity, where there's a clear trade-off between fairness and accuracy. And so my take on this is an accurate algorithm is not necessarily a fair one, because we need to distinguish between the predictive task of classification or making some prediction, assigning an outcome to a person that makes a prediction, versus how that's going to be used, which is an economic question. What is the impact of when I use this to make decisions on people's lives? What is it going to do to them? What is the effect on them and on society? So an example that I like to use is college admissions. So suppose you would like to use a classifier, a machine learning algorithm, to determine whether to admit people to a college. And so you could try to predict their GPA. But we all know that we have a leaky pipeline in STEM and in probably every field, and that can be impacted by unfair factors in society, like if you are poor or marginalized, you are more likely to get sick, you're more likely to have mental illness, you're more likely to have family members who get sick, you may be far away from healthcare where you live, and so you may be more likely to have your grade harmed and drop out. And so if you just try to predict GPA and use that to determine admissions, then your accurate classifier may not be a fair one.
So the way I think a lot of us are inviting more granularity around the term fairness, I invite more granularity around the term accuracy. So this is another one of those examples of technologists and non-technologists talking past each other. Accuracy means something very, very specific to us. It is a quantifiable value. Again, when we're explaining machine learning, supervised machine learning, as having your output, your accuracy is just a measure of how often your test data, your testing data was correct. We take our data, we put it into two piles, we train it on one algorithm, and we check our homework on the other. That is our measurement of accuracy. Now, is that a measurement of accuracy we believe in the real world? Maybe, maybe not. So one might say that, sure, minorities underperform. Does that mean that they systematically underperform, that there is something, that it is the action of being of a particular race that makes you underperform? No, we know that is not true. And this is why we're concerned about proxy variables. Another thing I'm doing additional research in, particularly in algorithmic determinism, is this concept of mutability and immutability of variables. Algorithms do not know the difference between things that we can change and things that we cannot change. I cannot change my age. I cannot change my biometrics, right? There are things about myself I can change, right? Maybe my educational attainment, my weight, my hair color. But an algorithm does not know the difference between the two. So when we think about things like accuracy, how much are we imposing that accuracy as this objective truth or this objective world order, and how is that related to systems of fairness and unfairness in our society?
So, fairness and accuracy. Let me go back to the Netflix example that you raised earlier. So accuracy, if a company is trying to assess accurately the taste of people in movies, there's a good chance you're going to get racial differences among groups. It turns out people's tastes differ by race. Now, should you try to fix this? Is there some unfairness involved in that? Well, you could move away from accuracy towards a kind of group equality, and your reasoning might be, well, you want people to have a diversity of experience. Maybe they'll see something that isn't part of their prior taste, and they'll learn a little bit more about the way other people live. But the cost might be that there'll be a mismatch between the recommendations and people's current tastes. And so there's a trade-off there. People have to think about which one they want as a matter of what we want our society to be like. But it's very similar to what's going on in the recidivism scores. But what this illustrates is that the way we make that trade-off and the importance that we ascribe to that trade-off differs by context. In the context of the Netflix example and recommendations for movies, there is one set of considerations. But in the recidivism situation, there are a whole bunch of different circumstances, but a very similar sort of structure. If you assess people's likelihood of reoffending, it's going to turn out that you're going to get racial differences. People reoffend at different rates depending on their group membership. Now, should you fix this? Well, there are a couple of very strong reasons for thinking that you should. One is that racial bias is endemic in the criminal justice system, and it's high time we did something about it. The other is that in the criminal justice system, one of the principles we kind of live by is to protect the innocent. We don't want to catch the guilty so much as protect the innocent. And so for both of these reasons, you might want to move away from just trying to get as accurate a predictor as you possibly can. And you can do that by using one of these other concepts of fairness, group fairness. You can, for example, equalize group error rates. The problem is if you do that, you lose something called predictive parity in the algorithms, and you raise all sorts of complicated legal, philosophical, and ethical questions involving a due process, constitutional questions. All of the difficulties about affirmative action are things you have to start to deal with. And there's a cost as well in terms of greater risk to public safety by taking that particular direction. Now, that's where you find the real ethical issues, right? In that kind of trade-off, you have to talk about it in the concrete context of some particular practice like criminal justice in order to really get your teeth into the ethical problems. It's not going to be solved, and we're not going to make progress at the level of debating abstract principles. You really have to look at those concrete cases to understand how to make the trade-offs.
Yeah, I'd like to sort of add a kind of practical note to this, which is that I think theoretically you can point to situations where there are real trade-offs, but practically speaking, in my experience, when you have a system, you identify some way that it's unfair, and then find a way to fix it, it actually gets better overall. And just to take an example, one of the most common reasons for a system not to be fair is that it's been trained on the wrong data that's not representative of what's happening in the real world, that it's being served on. And when you get better data, it's just a blanket improvement, or nothing gets worse overall. That's just a good thing. So in many cases, fairness is just a symptom of other underlying problems. And so I don't think that we should assume there's always a trade-off between fairness and accuracy.
Sorry, just to butt in, anecdotally, I have a similar example with our Accenture fairness tool. When we were using a credit risk modeling algorithm to determine whether or not system was fair or unfair by particular metrics, disparate impact, predictive parity, when we actually equalized for predictive parity by gender, we actually found our accuracy rate improved. It improved because we opened up credit opportunities to people who would previously have been denied. So absolutely agree with you that it is not always a foregone conclusion that fairness and accuracy are a trade-off.
I've seen a similar situation where overfitting is the problem. So you have a model that's too powerful, it fits too closely to the data, that can harm both accuracy and fairness, and I've seen it happen.
Naomi, did you want to weigh in quickly before we move on to an audience question?
Yeah, I just wanted to add, this is why we came up with a privacy risk model, right? Because when you're in a trade-off space, it helps to have a frame of analysis, right? And so that you can, in that contextual space, you can understand, well, what's the impact that, this measurement of accuracy is having, and, how is that impacting or creating problems for individuals? And then you can begin to make decisions and find the solutions that sort of both optimize your accuracy and also minimize those adverse consequences.
One of our audience members has asked, what are the main sources of data that are being used to develop algorithms? And if personal data are a source, how are subjects informed? And I want to relate that to a second audience question, which is, if the data are corrupt, is the fault left to data scientists, programmers, or someone else? And who is responsible for fixing the data?
I think those are both very incredibly important questions. So just getting at the concept of data consent, I think there's also an issue here where there is a misunderstanding in the public about what it means to give consent to data and what that relationship with people and data are. So I'm going to sort of answer the question, but maybe take the conversation to a little bit different place. Most people understand a relationship with algorithms and data, or data scientists and data, to be similar to when you would give your email address to get 10% off at some clothing retailer, and then they occasionally send you spammy emails. It's a very direct relationship. It's purely transactional. And I know the analogy is data is the new oil, but instead, I think of data as the new periodic table. Why? Because I can take the same element, hydrogen, and I can use it to make water, something that gives us life, or the hydrogen bomb, right? Something that can cause massive amounts of pain and destruction. And data is very, very similar. What we don't realize is seemingly innocuous data can be used in many different ways. You may not care if a company is picking up the number of steps you walk per day, but when that may influence your insurance premium, you will definitely care. The problem with getting consent is that we're not even sure what we're giving consent to, because the companies which we are giving consent to don't always know how they're going to use them. And also, are we giving data consent in perpetuity? What if now, 3 years from now, that is a very viable algorithm where the number of steps I walk per day crossed by other seemingly innocuous pieces of information plus the IoT from the publicly available cameras that are available in every smart city will then be used to actually measure my degree of health and therefore impact my insurance premium. What rights, when I agreed to share my number of steps, that algorithm maybe didn't exist. Now that it exists 5 years later, what rights do I have over it? And these are the kinds of questions that we're trying to understand and grapple with, and that requires a very fundamental reworking of our relationship as human beings with data. The other thing I would point out within the consent is, we can't, even if we take back our information or data or stop sharing, the historical information we have given, we don't have rights over that information. So what must we think about in terms of data we've already provided, or we have no control over what we're providing if we're in public, for example?
Erica?
Yeah, so I agree with that. I think that the question is such a good one about consent and consumer control over data. It is hard to sort of place and do the chain of activities that can be undertaken once data is ingested. And so one of the things, as I mentioned earlier, is sort of trying to do a risk assessment. And Naomi's talked about this too. It can be done through a privacy impact assessment and trying to at least identify what the risks are. One of the mitigation strategies that can partially address the question is sort of anonymization techniques or encryption techniques, but anonymization in particular, where you're separating the identity of the individual from that data. And so to the extent that data can be anonymized, may be a way to use the data. Somebody I think earlier talked about, in addition, differential privacy, where you're sort of, introducing noise to the data so it doesn't affect the integrity and the ability to use the data, but still protects that information. There are encryption tools like the homomorphic encryption is just an example, but there are strategies that potentially can be deployed to still allow use of the data without sharing or transferring some of that highly personal data.
So one last very quick comment. All the difficulties of getting consent that we've been talking about, I think that's one reason why the Nist framework that Naomi was talking about, where the way of thinking is identify a harm that is a possible harm, and then assess the risk of that harm, and then take steps to mitigate it. That approach, which puts a lot more of the burden on the data controller than on the individual data subject, may be a very productive way forward.
So the bad news is we are out of time, but the good news is that our next panel, after we have a 15-minute break, I think will be in a good position to pick up the discussion that we've covered on this panel. So please join Karen and me in thanking our panelists for a great discussion, and we'll return at 3:15.